Hi, my name is Martin King. This is part of our SMARTDROP series. I'm fielding a question today from Elizabeth. She's a senior PE down in Houston, Texas. Hey Elizabeth, thanks for submitting your question to us. This is going to be covering how economizers work in a process chiller application. This is a patented system that Legacy Chillers developed a while back, and we're excited to share it with you. And again, as always, submit your questions to us and we'd be happy to build them into our SMARTDROP series. Thanks again for joining us. In this SMARTDROP video, we're going to be talking about how process chiller economizers operate. Legacy Chiller Systems for some time has owned the patent on this technology, and I'm just going to give you a brief run through here on how this operates. So what you're looking at here is one of our package chillers, and I want to point out here that what we do basically is we take a standard package chiller. If you look really carefully here, you're going to see the regular condenser coil here, and then you'll see that we've married a microchannel heat exchanger up against the standard refrigeration condenser. So this allows us to keep the design very compact. There's no need for an external fluid cooler. And then we can also use the condenser fans for both economizer cooling and mechanical cooling. That's sort of a double duty feature. Now, one thing to keep in mind is we cannot operate this particular design in both economizer and mechanical at the same time. Our PLC will sort all that out, but that's one thing that that does not happen in this particular design. So this is a quick graph here on the savings. It actually can be quite significant, and what this is here is the delta T between the tank temperature, which is down here, and the ambient temperature. So if we have a call for cooling, for example, and we have a 20-degree temperature differential between the outdoor air and the tank, the economizer can actually put out a significant amount of cooling, right? So this is really great if you get into a situation where you have a higher set point. You know, let's say it's an MRI or a CT, and those things run at 55, sometimes 60 degrees fluid temperature, and you're in a very cold climate like Winnipeg or someplace in Detroit, Michigan. A lot of times the mechanical cooling can go to sleep around November and not actually come back online until April. All right. So we're going to take a close look on how this is plumbed. So this is, again, one of our PZAT package units. And this is a drawing of the internal plumbing system. And I'm just going to go over this real quickly, how this works. So you have two pumps in here. You have a system pump, which is optional. We have many sizes to choose from. We can put anywhere in most models from a 3rd horsepower all the way up to a 10 horsepower if we need to. So this system pump will draw off the tank, go out to the process, come back from the process where it's picked up heat, and back to the tank. So this is called our system pump loop. And then we have our tank recirculation system, and this is actually integral to the economizer process. So the recirc pump draws off the tank, goes through the strainer. In mechanical mode, the connection is made between A and C in this mixing valve here. So in mechanical cooling mode, it's going through to A to C through a check valve. Can't go this way because it's another check valve. This is a balancing valve for the pump through the chiller's evaporator, the refrigerant to liquid heat exchanger that's connected to the refrigeration system, and then back to the tank. Now, as I mentioned before, when there's a call for cooling, the PLC will, on an economizer-enabled chiller, will take a look at this tank temperature at the time of cooling call, and it's going to look at the outdoor ambient temperature here. So if it sees about a 10-degree differential minimum, it's going to go ahead and energize this three-way mixing valve here and make a connection between A and B. So it's going to force this fluid out, and basically this is the microchannel coil that we looked at a few minutes ago. It's going to put that in series. It's going to come through here with the evaporator and then back to the tank. So this is a normal flow pattern for economizer. All right. So what will happen is the PLC will run in this mode when you have a call for cooling, and what the PLC is looking for is it's looking for progress at dropping this tank temperature. The current software says that I need to be able to drop the tank temperature 1 degree Fahrenheit for every 180 seconds of operation, right? So if it's making progress, then it's gonna stay in economizer mode, and the mechanical mode is gonna stay off. So at any time, though, if the economizer cannot keep up, the PLC will automatically switch this back from A to C and put it in mechanical mode, start the compressor, and finish out the call cycle in mechanical cooling, right? So that's kind of how that works. This system is very, very effective, as I mentioned earlier, if you have high set point process and you tend to have cold outdoor ambient. So this is a very, very cost-efficient way, in some cases up to 60% savings if you have the right application in the right climate. All right, that is the economizer operation. I hope that information is helpful to you. All right, well, that's your SMARTDROP educational video for today. Thanks again for stopping in and hanging out with us for a little bit. If you have any questions that we can answer for you, please don't forget to submit to our LinkedIn, Facebook, or Twitter feeds. You can also go to our website and submit questions to us there. We're looking forward to working with you. And if you happen to have any process chiller needs, we're here to guide you through the process to a successful project. Thanks again. My name is Martin King. I'm with Legacy Chillers, and I'm happy to meet you.